Okay, in this lesson, we're going to talk about three topics that we've actually covered in previous classes, and that would be Pythagorean Theorem, which you've seen multiple times, special right triangles being 30, 60, 90, 45, 45, 90, which hopefully you remember from geometry, and trig ratios, which was also started in geometry. We're going to start out with the Pythagorean Theorem, and again, we remember the formula for the Pythagorean Theorem as being a squared plus b squared is equal to c squared. The most important part here is by knowing that A and B are what's called the two legs of the right triangle. And notice the arrow pointing to what's called the hypotenuse. The C is always across from that right angle. It's the hypotenuse. It's always the longest of the three sides of that right triangle. Notice that I am saying right triangle as well. This only works for right triangles. You cannot use Pythagorean theorem on any other type of triangle. So let's remind you on how to actually use it. It says find the missing side, give your answer in simplest radical form. Again, first thing you need to identify is your A and B. Those are your two legs. So in this case, my A and my B are 4 and 8. It doesn't matter which is which. My C value is across from that right angle, which would be x. So plugging it into A squared plus B squared is equal to C squared. We now have 4 squared, or 16 plus 64 is equal to x squared. We simplify 16 and 64, and that gives us 80 is equal to x squared. To undo a square, now normally when we undo a square, we do plus and minus, but since we're talking about a side length, we don't have to worry about the positive or negative. We're only going to do the positive square root of 80. Now, reminding you how to simplify radicals. We're going to try to figure out, we're going to see if we can split this into anything that multiplies to give us 80 that's actually a perfect root. And we go through our perfect roots being 4, 9, 16, 25, 36, and we start trying those, and we want to try to use the largest perfect root that we can when we're simplifying these, and the largest one's going to be a 16. 16 times 5 actually gives me 80. And we split this, and then we ask ourselves, okay, why did I split it? The square root of 16 is 4. The square root of 5, I don't know, so I leave it under the radical. So my final answer here is 4 root 5. Now, we do know that we can actually type that into a calculator, and we can get the approximate answer. The square root of 80 is somewhere around 8.9, and we could use that answer as well. But anytime it says to leave it in simplest radical form, they want us to simplify the radical and leave it there. Next problem, again, we're going to identify our A and B. Our A and B are the 22 and the x in this case. The C is always across from that right angle. So we now have, and it doesn't matter which is A and which was B, we have A squared plus B squared is equal to C squared. So we clean that up. A squared plus 22 squared is 484. 24 squared is 576. Now, notice when we're looking for one of the legs, we have a little equation we actually have to solve now. We're going to move our plus 44 over by subtracting, and that gives me 576 minus 44, which is 92. To undo a square, we're going to square root the other side, so we now have as an answer the square root of 92. We are going to try to split that. I do know that 4 times 23 multiplies to give you 92, and I know that the square root of 4 is 2. So my final answer would be 2 root 23, and I know that this is not going to break down again because 23 is actually a prime number, so there's no way that it's going to break down anymore. Okay, next part of the lesson, we're going to talk about special right triangles, and there's two very special type of right triangles that we need to memorize shortcuts for. And the first one being a 45, 45, 90 right triangle. And here's the shortcut for 45, 45, 90. Since the two angles are the same, that forces it to be an isosceles triangle, if you remember back from geometry. So what we're going to do is if one leg is equal to x, the other leg has to be the exact same value. So each leg will be x. And in order to go from leg to hypotenuse, if you know the value of the leg, in order to find the hypotenuse, you always multiply by the square root of 2. Now, this is only when you're dealing with 45, 45, 90s. Now, 30, 60, 90s also have a shortcut. Now, 30, 60, 90, one thing that you really need to understand is since 30 is right here, that's the smallest angle of the three, the side across from it will always be the shortest side. Now, you have two legs when you're dealing with right triangles. This is a leg, that's the shortest leg, and this will be the longer of the two legs. So anytime I'm talking about legs, make sure, and you see shorter leg and longer leg here, make sure that you understand that the shorter leg is across from 30, the longer leg is across from 60. So in a 30, 60, 90, everything actually revolves around this short leg. We're going to let it be x. The longer leg, in order to figure out what the longer leg is, you simply have to take that same value and multiply by the square root of 3 this time. So if the shorter leg is x, the longer leg is x root 3. Not to be confused with 45, 45, 90. Now, to find the hypotenuse, it's really easy. If the shorter leg is x, you simply have to double it or multiply it by 2 in order to find the hypotenuse. And that's going to be the shortcuts for a 30, 60, 90. Now let's actually use those shortcuts, and these should be super quick problems. Now the first problem is a 45, 45, 90. If you have a 45 and a 90, you understand the other one has to be 45. The two legs are located here and here, and the two legs in a 45, 45, 90 have to be the same. And if you have the leg, the value of the leg, in order to find the hypotenuse, which is in this case y, you simply have to multiply the leg length by root 2. So y would be 10 root 2. Another 45, 45, 90. Now this one's a little bit more difficult. Remind you that if you've got the value of a leg, in order to find the hypotenuse, you multiply by root 2. But now we're going backwards. So if you have to multiply by root 2 to give you the hypotenuse, to go backwards instead of multiplying, we're actually going to have to take that 16, we're going to have to divide it by root 2. This process is called rationalizing. It's a very simple process. In order to divide 16 by root 2, the method we're going to simply use is multiplying top and bottom by that same root 2. On top, you can't multiply 16 by root 2, so you leave it. On bottom, the square root of 2 times the square root of 2 is the square root of 4, or it just removes the radical. It's going to be 2. Square root of 2 times square root of 2 is just 2. Any radical times itself removes the radical. Now, I can actually divide 16 by 2, and that's going to give me a value of 8 root 2. And we know that in a 45, 45, 90 that both legs have to be the same, and they're going to both be 8 root 2. Now, you can check that. If 8 root 2 is the leg, if you multiply by root 2, it should give you the hypotenuse, and we know that root 2 times root 2 is 2, so 8 times 2 would give you that hypotenuse of 16. Number 5. Same thing, we're asking ourselves what multiplies by root 2 in order to give me 14 to root 2. Now the hard way there is from the previous is to take 14 root 2 and divide by root 2. And you could go through a long process there, but it just cancels. And if you just ask yourself, what can you multiply by root 2 in order to give you 14 root 2, I believe your answer would be 14. So both of those legs have to be 14. Now let's move on to 30, 60, 90s. And again, reminder in a 30, 60, 90 of the shortcut. Everything revolves around this short leg, the one across from 30. In order to find the longer of the two legs, you're going to multiply by root 3. In order to find the hypotenuse, you're going to multiply by 2. So first step, we need to figure out what this short leg is. So you simply ask yourself, well, what did I multiply by 2 in order to give me 8? And that would be 4. Or you can just divide by 2. And now that we know that this is 4, if we multiply that by root 3, that's going to give us the value of y. Number 7. This time you're given, and this one would be a little bit more difficult, you're not given the short leg, which is here, you're given the longer of the two legs. You go from short leg to the longer leg, you're going to multiply by root 3. So to go backwards, we've got to take that 27, or we're going to divide by root 3. And we're going to use that same process I showed you a while ago. In order to divide by root 3, we're actually going to multiply top and bottom by root 3. That'll be 27 root 3 on top, 3 on bottom because we're multiplying root 3 times root 3. And now you can actually divide, and that gives you a y value of 9 root 3. In order to double that, 9 root 3 times 2, Very simple process. You can't multiply 9 times root 3. You can't multiply 2 times root 3, but you can multiply 9 times 2, and that would give you 18, and we're just going to leave the root 3 alone. So 9 root 3 doubled would be 18 root 3. Number 8. Number 8, we are given the short leg. In order to find the hypotenuse, again, we just double that. So the hypotenuse will be easy. That'll be 10 root 6. In order to find the longer of the two legs, we're going to take that 5 root 6. We're going to multiply it by root 3. Now, this is going to be a little bit tougher problem. And you would think, well, it's going to be pretty easy because you can multiply roots. So root 6 times root 3, that'd be root 18. However, we can't leave 5 root 18 alone. We've got to do something with this root 18. Always try to simplify if at all possible. I know that root 18 can actually split into root 9 and root 2. And the reason I'm going to split that is because I know the square root of 9 is 3. So I now have 5 times 3 times root 2, which would be simply 15 root 2. Okay, the last portion of this this lesson is going to be trigonometric ratios and trigonometric functions. A trigonometric function is any function whose rule is defined by a trig ratio. A trig ratio compares the length of two sides of a triangle. And we know that ratios, again, like the ratios of boys to girls, the ratios of dogs to cats, the ratios of teachers to students. We've heard that word ratios before. We've heard gear ratios. Well, a trig ratio compares A's to B's, or compares B's to C's, or A's to C. And we've done these again in previous classes. And the way that we remembered these trig ratios is we remembered saw, ca, toa, sine, cosine, and tangent of an angle. The Greek letter theta is used to represent the measure of an acute angle in a triangle. Now, we don't always use theta. Now, there is theta. It's like a circle with a slash through it. Sometimes we'll use alphas and betas, but in this case, we're going to use some thetas, so we need to know what that Greek letter is. So if we remember SOHCAHTOA, sine, the S stands for sine. Sine is equal to the opposite side over the hypotenuse. The cosine of an angle is equal to adjacent over hypotenuse, and the tangent of an angle is equal to opposite over adjacent. So let's fill in our 3 blanks here. And there those are, but I do want to remind you of what we mean by opposites, adjacents, and hypotenuses. So if we're talking about angle theta here, which is this angle here, the opposite side is always the side across from it. So in this case, in this triangle, we're talking about A over, and C is always the hypotenuse. The longest side there is our hypotenuse across from the 90. Adjacent over hypotenuse, the adjacent side, okay, we know that this is the opposite. We know that this is the hypotenuse. The adjacent will also be next to that angle. In this case, our adjacent side would be B. And again, we've already said the hypotenuse was C. Our opposite over adjacent, therefore, would be A over our B value. Now, our reciprocal functions, I consider these as being like brothers. We need to remember that sine and cosecant is the word. Sine and cosecant are brothers. So if sine is opposite over hypotenuse, or A over C, then cosecant would be hypotenuse over opposite, or C over A. Secant is the brother of cosine. So since cosine is adjacent over hypotenuse, secant will be the reciprocal of that. And finally, it's easy to remember that cotangent is the reciprocal of tangent. And since tangent is opposite over adjacent, cotangent would be adjacent over opposite. Okay, to give us some practice of the trig ratios, let's work some problems. The first one, okay, well, before we can do anything, we need to know what this hypotenuse is. So we're going to have to use our Pythagorean theorem that we just learned. Now, I do want to show you something, though, that might be of some value. What I do is before I perform the Pythagorean theorem on a triangle, I will actually shrink the triangle down. And it actually saves you a step if you'll do this. I noticed that I could use similar triangles. I can divide both of these values by maybe 2. That'll give me an 8 and a 15, and that won't divide down anymore. And instead of using 16 and 30, I'm going to use my 8 and 15. I'm going to do 8 squared plus 15 squared equals c squared. That'll be 64 and 225. And that is 289 is equal to c squared. Let's square root it to find the value of c, and I get 17. What I've now got to do, since I shrunk this by 2 to find that answer, in order to find it, I'm going to blow it back up by 2, and multiplying by 2 gives me that this x value is 34. And again, what you're doing is you're actually dealing with smaller numbers when you do that. And you're actually going to see these numbers revisited, and you'll see what I'm talking about in a second. So first off, the sine. Here's my angle. Let's find our angle theta. Sine is equal to opposite, and our opposite side is here going to be a 16 over hypotenuse. The hypotenuse there is a 34. When we reduce that, and again, notice that I'm going to divide by 2 to reduce it, I get 8 over 17. The cosine is equal to adjacent over hypotenuse. The adjacent side there is going to be my 30. And again, we said the hypotenuse was the 34. Dividing by 2 gives me a 15 over 17. And finally, the tangent is the opposite over adjacent, which would be 16 over 30, which reduces to 8 over 15. Now, once you find sine, cosine, and tangent, the other three super easy because all you have to do is reciprocate them. If sine is 8 over 17, then cosecant will be 17 over 8. Secant will be 17 over 15. And cotangent will be 15 over 8. The next problem says, given the ratio for cosine, find the remaining ratios. So we have a triangle. Here's how we're going to work this. We have a triangle whose cosine is 2/3. Now here's all we have to do. Here's my angle theta. If I know my cosine is 2 over 3, well, I also know that cosine is equal to adjacent over hypotenuse. So let's just label our triangle accordingly. Adjacent is the 2. The hypotenuse would be the 3. Now we will probably, or excuse me, I labeled that wrong. The adjacent side is 2. The hypotenuse is 3. Now for this problem, we're probably going to have this opposite side. So let's go ahead. Let's do our Pythagorean theorem here. And this won't shrink down any, so we can use the 2 and 3. So we have x squared plus 2 squared is equal to 3 squared. That'll be x squared plus 4 is equal to 9. Move the 4 over by subtracting, gives me x squared is 5. So x must be the square root of 5. Now the rest of this problem will be fairly simple. To find the sine, well, sine is equal to opposite. There's my angle. Opposite would be √5. Opposite over hypotenuse. I've got my cosine already. My tangent is equal to, and again, you can always remember SOHCAHTOA. So tangent would be opposite over adjacent. So that'd be my √5 over my 2 would be opposite over adjacent. And to find the other three, again, all we have to do is reciprocate. Now notice that when I do reciprocate to find cosecant, that puts that √5 on bottom. So we do have to rationalize by multiplying top and bottom by that √5. That gives me a 3√5 on top and a simple 5 on bottom. And that will not reduce. If cosine is 2/3, then secant will be 3/2. If tangent is √5 over 2, then cotangent will be 2 over √5. And again, we have to rationalize. And that gives me 2√5 on top. Can't multiply them. It gives me a 5 on bottom. Okay, the last part asks us to actually combine two of the previous parts together. It says angles 30, 60, and 45 are frequently used in trigonometry. You can use your knowledge of the side relationships of special right triangles to find the values of some trig ratios. So let's go to our 45, 45, 90, and remind you that the two legs are always the same. And in order to find the hypotenuse, you multiply by √2. In a 30, 60, 90, everything revolves around the short side. So if you have the short side, you know the hypotenuse is double it. And you know that the longer of the two legs will be √3 times the shorter of the two legs. So what we're going to now do is use that to find some exact trig values. The sine of 45, and you could actually type this in our calculator, but as we progress, we're going to memorize these values, so we really need to know what they are without a calculator. So sine of 45, we can actually pick either one of these. I'm going to use this one. Sine is equal to opposite, and we know that the opposite is over here, over hypotenuse, and my hypotenuse is x root 2. The x's actually cancel and leaves me with nothing, so I'm going to put a 1 in its place, 1 over root 2. We're going to rationalize by multiplying top and bottom by root 2, and that will actually give me root 2 over 2. That's the exact value of the sine of 45. Let's now do the cosine of 45. We're going to use the same 45-degree angle, but cosine is adjacent over hypotenuse. So you actually get x over x root 2, the exact same thing. So we're going to come up with the same answer there. The tangent of 45, let's use the same 45. Tangent is opposite over adjacent, which is x over x. Anything divided by itself is 1. The tangent of 45 is actually 1. Now let's do the same thing with 30 degrees. Here's my 30-degree angle. Sine of 30, sine is equal to opposite over hypotenuse. That'd be an x over a 2x. Notice again that the x's cancel. Anytime that everything cancels, we always replace it with a 1. So that would be actually 1/2. Let me try that again. So the sine of 30 is always going to be a half because, again, if you think about it, since the hypotenuse is always double the opposite side, then once you divide opposite by hypotenuse, it's always going to be a half. Next up, we're going to do the cosine of 30. Cosine is adjacent over hypotenuse. So that's going to be x root 3 adjacent over hypotenuses. The x's cancel and leaves me with root 3 over 2, which is always the cosine of 30. The tangent of 30, tangent will be opposite over adjacent, which would be x over x root 3. And again, the x's cancel, leaves me with 1 over root 3. When I multiply top by root 3, it gives me root 3. When I multiply the bottom by root 3, it gives me 3. So the tangent of 30 is root 3 over 3. Next up, let's do the sine, cosine, and tangent of 60. So let me erase here. And we're going to use my 60-degree angle now. So you can see it's pretty much the same triangle. So we're going to get very similar answers. Sine is going to be opposite over hypotenuse. So that's going to be x root 3 over hypotenuse, which is 2x. The x's cancel and leaves me with root 3 over 2. Notice that the sine of 60 is very similar to the cosine of 30. Let's do the cosine of 60. Cosine is adjacent over hypotenuse, which will be x over 2x. And just like above, that's also going to be a half. And finally, the tangent of 60. Tangent is opposite over adjacent, which would be x root 3 over x. The x's will cancel and leaves me with just plain root 3. So this is the start. Very important that we know where these values are. But this is the start of bigger things as we get into unit circles and we get a little bit deeper into trigonometry. So we need to make sure that we do have memorized our shortcuts, and we know that those shortcuts can lead to exact values of sine, cosine, and tangent of 30, 45, and 60 degrees.